Hello, everyone. This is Zhiru Zhang from Cornell. I'm excited to participate in ISPD and have the opportunity to discuss with other distinguished panelists about topics that overlap with EDA and specialized hardware design. This is certainly an exciting time to work on hardware specialization. There's a strong demand for emerging applications to not only run fast, but also use less energy. Currently, building special purpose hardware is arguably the best way to achieve this goal. Plus, the barrier is lower now to start a new hardware project, thanks to increasing availability of open source hardware and cloud-based acceleration platforms. Talking about making hardware design easier and more affordable, open source EDA tools are also catching up. Here, I'm just showing a subset of the tools that cover different areas of EDA, such as physical design, logic simulation and synthesis, and high-load synthesis, or HOS. In fact, some of these tools are already being used to build high-profile hardware, like the Google VCU, which speeds up YouTube services. This is certainly very encouraging news, but there is a catch. Right now, only large enterprises like Google can afford to invest in this practice. They have the resources to finance a big team of hardware, systems, and compiler experts to build the new accelerators and the software stack, but only for high-value applications. So in other words, even though hardware specialization shows immense potential across a wide range of domains, it is only within reach for a few right now in practice. This raises the obvious question: can we empower a small team of domain experts to develop and use accelerators in a new domain, not just for high-value apps, but also for the long-tail ones? So here's the main point I'm trying to make in this talk. We need EDA verticals to make hardware specializations more widely accessible. The idea is to enable domain experts to create fast hardware using the programming interfaces they already know. But I'm not really advocating for building one-off unique tool stack for each new domain. This is just not practical. Instead, what we need is an open, customizable infrastructure with standardized interfaces to maximize reuse across verticals. And at the same time, we want to take advantage of cross-layer optimizations where domain-specific context can be leveraged, not just at the top level, but across the entire stack. To be more specific, here's my panel statement. We need improved design abstractions, not just higher level ones. We need to develop systematic methods and formalism for exposing the search space, costs, and constraints. We also want to provide open and interoperable interfaces to facilitate customization. If we can achieve these goals, we can really enable the construction of extensible DA infrastructures and reusable libraries. So these will allow us to achieve rapid customizations of DA tool stack for novel domain. So basically building these EDA verticals. And as a result, we can achieve this productive end-to-end mapping from DSLs to accelerators. My group at Cornell has been working hard towards these goals. Without delving into the details, I invite you to check out HydroCL, which builds on MLIR and is meant to serve as a bridge between DSLs and HOS. HydroCL introduces a set of well-defined hardware customization primitives that are decoupled from the algorithm specification to enable more productive and portable compilation flow. I also invite you to take a look at AutoBridge, which is a joint work with UCLA Professor Jason Kahn's group. This is where we vertically integrate HOS and physical design, special floor planning, to improve the frequency of FPGA HOS designs by more than 2x. There's also a follow-up work to AutoBridge, which is called RapidStream. So this is where we further collaborate with AMD Xilinx and leverage their open source rapid write tool to dramatically improve the compile time from HOS all the way to layout. And we can actually improve the compile time by, in many cases, up to 10x. So in fact, HydroCL and AutoBridge and also RapidStream, they're all released in open source format. With that, I'll stop here, and I very much look forward to the panel discussion. Thank you very much.